working with like the South Park studios. Like they're making like a new episode, and like they'll be using one of our voices also for one of the characters. That's super exciting. Like, oh my God, like these voices not being used in production, actual shows. And we started with traditional text-to-speech use cases. The main driver for us was to do that investment because it was like very risky. So we did all like that investment because we wanted to get into that market of like the human voice, like all voiceover actors and the opportunities this can open, because this for the first time ever you're automating the human voice.
Hello, and welcome to the Cognitive Revolution, where we interview visionary researchers, entrepreneurs, and builders working on the frontier of artificial intelligence. Each week, we'll explore their revolutionary ideas, and together we'll build a picture of how AI technology will transform work, life, and society in the coming years. I'm Nathan Lebenz, joined by my co-host, Eric Torenberg.
Before we dive into the Cognitive Revolution, I want to tell you about my new interview show, Upstream. Upstream is where I go deeper with some of the world's most interesting thinkers to map the constellation of ideas that matter. On the first season of Upstream, you'll hear from Mark Andreessen, David Sachs, Balaji, Ezra Klein, Joe Lonsdale, and more. Make sure to subscribe and check out the first episode with A16Z's Mark Andreessen. The link is in the description. Omniki uses generative AI to enable you to launch hundreds of thousands of ad iterations that actually work, customized across all platforms with a click of a button. I believe in Omniki so much that I invested in it, and I recommend you use it too. Use CogRev to get a 10% discount.
Mahmoud Felfel is the CEO of Play.ht, the AI-powered text-to-voice generator. We've told you episode after episode that transformers are working for everything, and that includes generating what Play.ht calls ultra-realistic human voices. When Mahmoud started Play.ht just 3 years ago, serviceable but obviously robotic text-to-speech services were the standard, and neural voices were just getting started. Just 2 years ago, a custom voice with a leading provider required hours of audio and cost $10,000. Today, I can clone my voice with just 10 minutes of audio at minimal cost in less than an hour. I can hear myself reading content just like this. And just as in other subfields of AI, progress is not slowing down. Mahmoud talks about the next generation of text-to-voice models working more like image generators do today, with a rich prompt space that allows you to effectively direct the quality of voice output. If there's one AI development society has predicted, and which is very intuitively dual use, it's deep fakes. But somehow they are already here, and we are definitely not prepared. Already on TikTok, I'm seeing creators say that their families have been scammed and starting to recommend family passwords that impersonators wouldn't know. Now, I was genuinely impressed with Mahmoud's approach to user safety and preventing abuse. To his credit, he does have a multi-pronged approach. But it seems like there's only so much builders like Mahmoud can do to protect us from the downsides of AI. And we're likely going to have to figure out how to deal with a world of convincing deepfakes quickly. And as much as that does worry me, I also share Mahmoud's amazement and delight over the technology and the products that he's able to build with it. Making this was easy, quick, and genuinely fun. And I hope you enjoy my conversation with Mahmoud Felfel. Mahmoud Felfel, welcome to the Cognitive Revolution.
Thank you. Thanks for having me.
Yeah, my pleasure. I'm really looking forward to this conversation. But you obviously are the founder and CEO of Play.ht, and you guys are in the, what would be traditionally called the text-to-speech business. You might also call it the voice generation business, as we'll get into a little bit later. You might even call it at least the audio side of the deep fake revolution that's kind of coming our way. So I'm really excited to talk to you. I've been personally a customer, and I would say, pretty demanding, kind of exacting customer in the space of the technology that you're building. Because at my company, Waymark, we make TV commercials for local and small advertisers. And, it's really appealing that we want to use technology to do that, right? It gives speed, it gives, cost effectiveness, which is hard to match with any sort of service. But, no matter how small the business, no matter how small the budget, folks want to sound good. They do not want it to sound like it was made by a robot. So I've personally spent, quite a few hours going around and shopping for all the products, testing all the APIs, And what you guys are doing with the ultra realistic voices is, really among the very best products out there today in terms of how it sounds, how easy it is to use. So I'm really interested to get into all of that technology and, start to pull apart how it works. But first, I just wanted to ask you a question, kind of about the start of the business, because I think there's maybe something pretty interesting here. When I was first shopping around and used Play.ht, it wasn't quite clear to me, but I got the sense from using the product that the first thing that you had launched was essentially an API wrapper around text-to-speech services that were already offered by the big tech companies, your Googles, Amazons, maybe even like an IBM or a Microsoft. I don't know who all had offerings, that you guys were making available. I'd love to hear the backstory of that. That seemed like a really smart strategy to me, because obviously those things are reliable and they were pretty close to state of the art, if not state of the art, and they were fast. Also, by reselling them, you have an unbelievable window into how customers like or don't like those services and where they're falling short. So tell me about that kind of origin story.
You're right about like what you said, and we started by using these like third-party APIs from AWS, Google Cloud, IBM. I mean, IBM was like the first one. IBM Watson. I think the first, even before AWS released like Poly, and Azure also released their like text-to-speech voices. Like we started with that one. The reason we started with this product is that like me and my co-founder were like working together, like software engineers. We were like always like tinkering with like different things, like trying to solve different problems. And we started like maybe, I don't know, like over a couple of years, like 10 ideas, all failed. And and then at the end, we were like literally taking a break of like working on anything. I like listening to audiobooks. Like I have like 2 subscriptions to Audible or something. So, I didn't find the same with articles. Like at the time, that was like maybe 4 years ago, like Medium was like pretty big. And there were many writers coming to Medium. So I find like this one place where all writers is there, and like I'm reading a lot of like Medium articles every day. I start to think like, okay, like I need to listen to this, like when I'm running or like doing anything, like how I do with audiobooks, right? But there was like no way like to do that. And then I started to look into, okay, what's available? Can this be automated? And then I found like IBM voices, and they were actually pretty good. Like most of the voices in the market at that point was like very robotic. They're not like, you cannot consume they're not consumable like for people, and I wouldn't stand listening to that for an hour or something. But the IBM voices were actually pretty good, and they're still robotic, like they're like Alexa-like voices or Siri, but you can tolerate listening to them for like some time. And so we built I suggested that idea to like my co-founder, and we started building it. We built I started with a Chrome extension for Medium, just for like basically building it for myself. And we put it on Product Hunt. Actually, we didn't put it on Product Hunt. Like someone like I don't know found it on Chrome, in like the Chrome store, and put it there. And we got like so many people using it. Ask it for mobile apps. We built mobile apps, and like there was like a lot of traction on that. Like listening to audio articles, we started to think about like, okay, this is becoming like maybe a little bit big. Like, let's focus on this and make it like a business. We started to think about monetizing it. Then we started to see like it was like very hard to ask people to pay for this. They want to like consumers, they want to consume more and pay way less. So and if you go the route of audio ads, that also wasn't very appealing to us, like to try to source ads and services to users. I mean, it's annoying even to us to have audio ads, so we didn't want to add this to the product. But at the same time, we noticed something that like many of the users of our application and like the Chrome extension were actually people who have already publications and have like blogs or actually using Medium themselves as writers, and they have like big audiences, and they're asking us, okay, like this is very useful, like I love it, I want to listen, I want my readers to be able to listen to my content. So we saw an opportunity there for having this as like a B2B product or like a SaaS product, where we offer this like audio articles product where writers and or publications in general can add this. And now like there are many publications now, I mean after that time many publications have this now. You can listen to the article when you go there. So that was our target at that point. Yeah, and we did this product. We started getting some growth there. It wasn't like as big as what we hoped for, but we started to get a feeling of like building a B2B product, SaaS business, and what people are expecting. And the problem there is that we start to found like this is like the audio articles product was more of, like this thing of like vitamins versus like painkillers. It was like a good to have. It was like no one, like most people wasn't like searching or trying to find a solution for an audio articles problem, right? It's a good to have. Like if you have a publication, I mean, writing itself, generating the actual articles, that's a problem. But then once you have that, adding audio articles on top of this seemed like it's a good to have thing. And we didn't get like a huge growth there. And at that time, COVID hit, and we have built this on top of these like APIs. We have built that editor that has, basically took all the capabilities of these APIs, customizing the SSML and like everything there, and like just taking this and making it visual where people can, easily create content using these like text to speech engines. And we found that there are many customers coming using this for other use cases. And when COVID hit, that like some of these use cases were in like learning and development and like others. We can get into this more, and actually why we started investing in our own like in-house models. It's related actually to the point that you just mentioned, that people, like regardless if it's a small or big company, they want the best quality, right? And we started to see this in our users. That was the main reason we started to invest in training our own models, because we found, okay, these like generic APIs from AWS or Azure, they are good, but they are not built for like the use cases we're trying to serve. And they are still very robotic. So we saw, if we want this business to really grow, we have to, we either sell it and do something else, or we have to solve that quality issue to make this voice like human-like voice. And we started investing in training our model. We can get into this more.
Yeah, that's really interesting. You're one of a couple of different entrepreneurs now that we've talked to who actually started a company that was not originally an AI company and has become an AI company. You guys started with kind of a problem, an observation, and it sounds like above all, kind of creating an accessible product experience that, people preferred to having to go to AWS Poly and figure that out directly. And then, kind of you're midway, and all of a sudden what is possible with AI changes dramatically. So did you run into any challenges, in kind of reselling those things? Like, were the platform, companies nice to you as you went about doing that? And how much of that is still like the usage that you see in the product today versus all the new stuff that we'll talk about next?
Yeah, actually, so we built, like, I think a very good business, or growing very fast on these APIs, because we're mostly solving problems. Like, end of the day, we are like in this like tech bubble, so we're really interested in tech and like fancy stuff. But end of the day, consumers don't care about like what's happening in the background. Like, is it your model? Is it an API? Is it whatever? They have a problem and they want it solved, and solved well. Like, like this, like jobs to be done, like approach where the job here is to create good quality audio out of this. And like these were like good enough and fast enough to solve that problem, and like to a point. And that point was the quality. Whenever we started to look into the high-end use cases, like as you said, with audio ads, with gaming, like gaming companies, like most of gaming companies today, they don't use text-to-speech in production. They use it only for like scratch audio, where like when they're developing the game, they just fill in like some, like characters with voices. But when they go to production, they get actual voiceover actors to get like the, that feeling and like expression and all of that. The same for like media production and like in general, like in all, like in different, like all the high end use cases, even in audio articles. Like whenever we try to reach to like New York Times or like any like big publication, they who care about their brand, they would complain about quality. Okay, this is not good enough for our users. So we found this is the biggest hurdle. Like if we manage to solve that problem, this will be a huge, because then you moved from the traditional text to speech market to, which is like learning and development, IVR, like these things, to the human voice market. And that's like a huge market. Like the use cases are like huge there, and the potential also. like these platforms, there was no problem at all. They provide an API. We were able to scale very well, and we're still using them until today. We launched our own model. I mean, we started working on it like more than a year ago, but we launched it around 5 months ago. And over these 5 months now, our models are serving around 60% of our usage. And we have like millions of like conversions every month. And now 60%. I mean, it didn't actually drop like the old model usage didn't drop. It has been like growing, but also our models came up and now it took over that. And the reason like these people still using the old models like or these like APIs mainly because of languages. Like our model now is still only in English, and these other models they have like a much bigger like maybe I think 130 something like languages and accents inside each language and everything. So that also has like a lot of usage.
I'm reminded of the very first episode we did, which was with Suhail Doshi from Playground. He told us a couple of fascinating stats. One was that a full 10% of their users make more than 1,000 images a day, which I still kind of, shake my head at and try to imagine what that really means. But then also he said at one time they found a latency bottleneck in their system, fixed it, and generation got twice as fast. And he said they immediately saw essentially a doubling of usage with that change, kind of a step change. Like people were just, ready to use all of the generation that they would give them. So your story is kind of similar in a sense that you had this kind of breakthrough of quality with the new ultra realistic voices, and it just unlocks more use cases, more market opportunity. And it's really fascinating to know that the, kind of big tech, last generation stuff not only continues to play a significant role, but even, continues to grow. So that is very, very interesting.
I mean, we have something similar also. I think that like people are starting really to like use this and change their content creation flows completely because of these technologies, like what like Playground is doing and like we're doing and others. Like we have some users that told me like on calls, we are spending 12 hours per day in our editor. I was so surprised. Like I am not spending 12 hours a day in our editor. Like they're like creating like complete audiobooks, podcasts, like, and they're very careful, like choosing characters and like, editing everything. They're really designing the experience. Initially, we thought like people would use this just to replace, to be like a quick thing, to get something out. But people are very deliberate about these things and trying to have like think about like the listener, how they will listen and like have conversations with different voices and like the voices we do and how the conversation will flow from one character to another and all of these things. And that's just so inspiring to see like how people are using these tools.
So tell me about the process of, I guess, first of all, becoming an AI company. I'm sure you had to, learn a lot yourself. I'm sure you had to go hire new people that brought critical skills to the team. And then it sounds like you spent more than half a year working on your first in-house model before you're able to launch it. So tell me about the process, but then also the technology itself that you've built.
Actually, from the beginning, we have been very involved because like me and my co-founder are both software engineers. So like the most natural thing was not to use the APIs from these platforms like AWS and others, but to just go and do our own and deploy our own models. But the problem there, and like actually many other companies in the market, they did exactly that. They just went and they trained their own models. But what we found, the maximum quality we were able to get, like whenever we take these models, fast speech, tachytron, like this, like the ones available in the market, and we train them, the best result you can get is similar to what you get from the API. So it just didn't make sense. Like you will invest and you will have like a machine learning team in house and like doing a lot of like research and training and stuff like this. And at the end, like getting the same quality and the same like value you're getting from these APIs. At the beginning, that didn't make sense. And we continuously almost every open source project or research paper came out about like text to speech in those 2 years. We were like in touch with the person who did it, and like we had a call with them. Like whoever open sourced something, we have to try it. But we never found something that's really a breakthrough. But at that time, like beginning of 2022, we started to see that shift in the architectures. Like DALI was there, GPT-3 was there for some time, and diffusion models, and there was that shift. Okay, so now, because the problem with text-to-speech, like standard text-to-speech models, that they are they're not self-supervised, they're like supervised learning, where you have, say, 20 hours of Nathan's voice for like recorded in a studio, and then you take that and you train a model on these 20 hours. So the model will generalize on like how to speak like your voice, like this, like Nathan's voice, and that's it, not how to speak like a human. And that's why the voice that's generated in a studio from one person, it is really hard to make the model generalize from this to be able to speak like so many other voices and be very emotional. And like basically, if you want the model to speak a different accent, you will have to get someone speaking that accent and train the model in that accent. If you want the model to speak in like specific emotion, you will have to go and get someone speaking that some data set, and you label it like this, and you do some conditioning to the model to be able to generate that emotion, which is a very hard process to do, especially if you want to scale to so many voices. And then if you want to go into voice cloning, that's almost impossible. What we found at that time, that now with self-supervised learning, where okay, now you can train this actually on a huge data set, on like hundreds of thousands of voices maybe, and there are already some, like the good thing is there are already like very large data sets available, like Common Voice from Mozilla, and like many other like VoxLib, like which like some audiobooks, public domain audiobooks available. And I mean, you have the internet, right? Like you can also use, like there are a lot of data available on the internet where, and now with like self-supervised, you don't need that data to be like the best quality. You basically training the model how to speak like humans. And then after training this large language model, it's not very large, just like around like I think almost like 300 million parameters. So it's actually very medium model. Right now we have another one now that's actually large. I can't tell you why we trained another model and everything, but that one, the first one wasn't that large. And but the reason it got very good is that because the data set is big, and then we started to see some stuff that we didn't expect to happen. Like the model started to have these representations about emotions, and if there is a sad text, and just like this, that stuff was mind blowing to us. Like you have the same voice, everything, and you have the same text that's very sad tone, like oh no, like stuff like this, and another text that's like oh my god, wow, and the voice will be completely changing between those two just by changing the text. It was just the model has started to have these representations of like what is a sad voice sounds like, and what is like a happy voice sounds like, what is an excited voice. And because in all the pairs of text and clips we trained it on, like must have seen when someone is saying oh no, it's usually very sad voice. So it started to have like to attach this to that type of text, and now it can just from text extract these emotions and this style. So when we saw that like change in architecture, like transformers and large language models, that was the reason we started to like invest in this. And it took us like, actually we had the model like very early, like we had some good results, but it was very slow, like to generate. It took like maybe 20 minutes to generate like a minute of audio, which like just impossible to use, right? And we spent maybe 6 months until now. Actually we're still like optimizing the performance of the model. Actually probably in the next couple of weeks we will have like a real-time streaming API. That's like something that we have been like to think about how it was very slow at the beginning, and now we're coming to real-time streaming. It's so exciting.
Yeah, I love your enthusiasm for this too. And I feel the same way. It's crazy just how much things have improved in such a short time. Like we're seeing multiple orders of magnitude improvement, in like a year or 2 years on some of these things. Just really incredible to see. What can you tell us kind of about the architecture? It sounds like from what you're saying that it's a transformer based approach, as kind of increasingly everything is these days. Do you use like any sort of off the shelf language model as kind of a base to get started? Do you have like for all the different voices that you have, is that kind of a single core model with like different decoders at the end that kind of create the ultimately different sounding voices? You can go as much detail on this show. You can go into as much detail as you want to share.
yeah, it is like a transformer-based model, and honestly, that's not like a secret. Like you can see now. I mean, I will not get into like a lot of details about because it's not like one model. It's like a pipeline of things that the engine rates the audio. Because all the models like you that works like in text to speech, you usually don't use waveforms. You don't use audio when you're like training or like using the model itself, but you use like millispectrograms, which is like a representation of audio, like that can be compressed and used much more efficiently. But and then at the end you turn this, you use vocoders to turn that into like high quality audio, and the vocoders have been something there like for a very long time. So, but the main model we're using, you've seen, I'm sure you've seen like some of these papers like Valley and like AudioLM and like this model. I think people are starting to come up with like similar ideas, like using transformers, training on like a large data set. I think like Valley was trained on like 40,000 hours. And I'm not sure about AudioLM. Like I don't think they released like a lot of details, but like I think these models will start to come up and like they're basically very similar ideas. Like there are a lot of details inside the model, inside this pipeline to make it, because like one problem with large language models that it's maybe good for images, but it is terrible for something like voice, is that these models are like non-deterministic, right? Like these large language transformer models. Like, but with something like voice, you want it to be deterministic. You want if something like a specific word to be always pronounced like the same way, right? Or a specific acronym, for example. So this also introduced a lot of challenges that we have been solving and like working around. But yeah, like so it is like as you say, like transformer based model, like large language model, and I think the trick mostly is also in the data set, like what type of data and how to load this data. And like another problem we faced when we're training the model, because there is no infrastructure out there for training large language voice models. So we had to literally build in our entire infrastructure from scratch, like how to process this data and how to load them into like multiple GPUs for training, and like the data set also part, and the diversity in that data set, what voices, what accents, like how long are like the data like pieces or clips you're training the model on. Like there's so many details there that are important in generating something that's high quality. You said like different voices. How does this work? So like the way it works now is that you can sample from the model itself. The model can talk in like basically like 100,000 voices or something. So you can sample almost any voice from the model. But what we did to make sure we have the highest quality, we actually went and we got some voiceover actors who we know, okay, they have like specific accent or like something like specific we need to have on our platform. And we got like for 4 or 5 hours of each one. And then we fine tuned the model on these voices. So now the model like, and then there is like a copy of the model that can speak like that person. So and it needs only like 1 hour to 4 hours, something like this. And yeah, we were able. So these other voices we have now on the platform, they're all like voiceover actors that we worked with, and we got them to record their audio for us and in different styles, and then we fine tune the model on that, and we make that available to users. But everything is built on the same base model, basically.
When you mentioned the spectrogram, some folks might have seen a recent like text to music project that kind of circulated quite a bit, where you would see the spectrogram that would then be translated to the music. So that's quite a fascinating pipeline that it ultimately kind of ends up going through this like visual representation that then gets translated to the audio. I found that fascinating. It's cool to know that you're doing something similar there.
Amazing project to see, yeah.
So what are the big use cases that you're now tapping into with the ultra realistic voices? I got to give a plug for the podcast that you're helping to produce with Reid Hoffman. I think he calls it Chats with GPT, where he's literally like sitting, virtually, metaphorically, whatever, alongside ChatGPT and having a conversation with it that turns into a podcast. Play.ht powering the audio of that. Is that like a very random, far out use case, or are you seeing more and more of that kind of stuff? Like, what are people doing with it now?
Yeah, actually, we see a lot of like people using that for podcasting also. Another thing interesting also that probably when this episode is aired, it will be already live. Like we're working with like the South Park studios. Like they're making like a new episode, and like they'll be using one of our voices also for one of the characters. But like just like that's super exciting. Like to see this, like, oh my god, like this voice not being used in production, actual shows and HBO. Like so this is like just another example of like these use cases. So, and I think this is exactly what we wanted to do. Like when we started with the use cases for L&D and IVR and the traditional text-to-speech use cases, the main driver for us was to do that investment, because it was like very risky and we didn't know if that will even work. No one like did something like this before. And when the model was like generating in 20 minutes, that's not usable. We didn't know if that's even doable to reduce it to something like usable by users. And so we did all like that investment because we wanted to get into that market of like the human voice, like all voice over actors and the opportunities this can open, because this for the first time ever you're automating the human voice, right? Like anything that can be done by a human, like stayed like it now can be automated. Like, and you can think about gaming, like production use cases for gaming. Right now we're working with multiple gaming studios where they want to create fully dynamic experiences. Like usually you get in games like some characters they will have voices, and if all the NPCs in the game will have like bubbles, right? Like just there's no it doesn't make economic sense for them to get like 100 voiceover actor like recording all the characters, right? And now the other like layer on top of this, they wanna like players to have a conversation with the character, with the NPC in the game, and that's something that's just not doable. Even if you have like all the resources, you can't make this work. And the same, we're working like with like another like streaming, very famous like streaming service now. That they create podcasts, and they want to use this to create also dynamic experiences for people listening to the podcasts. Hi Nathan, in today's episode, like you'll see what so these things are just like these markets. It's not like something that's already existing and we are plugging, like replacing it with voice. It's just opening complete new markets. So we're very excited to see these new use cases coming up. And so since we launched this, we have been seeing also a lot of creators. We're getting a lot of YouTube creators now coming and using these voices every day. And they usually, we have seen like two use cases there. Either they're a non-English channel, or like the creators of the channel, not English speakers. And now they are telling us it's like we have hired, a couple of like British and American accent people in the team. They can now create videos for us. It's so empowering. And like the other use case where creators are cloning their voices, so they're starting to create more content. So instead of like you have to go to the studio a couple of times a week to do an interview or like to record a video or like a product review or something like this, now you can just have the video, write the text, and then have that on top of the video in minutes. That used to take like a long time to do. And like we are very interested in the use cases around voice cloning as well. That's like one of the things that we have been investing in, and we're very excited to see like what people are coming up with.
Just want to talk a little bit about the challenges that you guys are still facing. Obviously this technology is maturing rapidly, and the fact that you're doing stuff with South Park and HBO and all that, that's incredible. I'd love to just kind of understand like what some of the trade-offs are that you are facing, and what kind of some of the challenges are as you go toward this more ultra realistic approach.
The reason like these other models, like they have all these features like SSML, and you can control styles and that stuff, because they are very mature. Like they have been in the market for a very long time, and people have been working on this for a very long time to add all these capabilities. But on the contrary, with like the large language model approach, we literally like just did this like 5 months ago, right? And have been so focused on performance and optimizing it to actually work like in almost real time or as close to the existing models as possible. So it will be usable for users. Because when I tell you like someone is like staying for like 12 hours a day working on this, if that takes, each generation takes like 1 minute more, that's what he will be taking like another be like a long, like way longer process for him, right? And that creative process, the feedback loop is very important. That you create something, you listen to it, you see how it sounds, you try different voice, different characters. So we wanted to make that feedback loop as fast as possible. And I think we did it. But right now, and the reason that I told you we trained another model that's actually much bigger and solving many of the problems the first model had, one of these problems are actually these like pronunciations and the control of on the voices. Right now, we have a lot more control on like adding things like emphasis, like to specific word, or adding like pauses, or make the voice speak in a specific style, like for example, like an audiobook, like a narrative style, or a commercial style, or a training, like an instructional style, like these things where it's still the same voice, the same everything, but then it will not be as dramatic if it's instructional, for example, or as emotional. And then there was some styles like meditation or these things where it was actually very hard to get the voice to completely change its like way of speaking. But so this new model is solving like most of these problems, and over time we're adding more and more of this control. Because if you're thinking about this model for the users, if you now think of like for the job to be done, this model for the user is like a human voice over actor, and the user needs to tell him, no, like, speak in, like, say this thing in a different intonation, like be more excited, like increase your voice here, or like this pronunciation needs to be a little bit different. It's like, how would you actually tell an actual human voice over actor, right? And we are seeing that feedback from users now, and we were surprised at the beginning. I mean, that's like way better than the other voices. Why people are complaining about these things? Because now they are not comparing it with text to speech, they are comparing it with humans. And that was like complete shift in like the mentality that, okay, actually this needs to be directable. Like you need to be able to direct that voice exactly what you want, like what you're saying, like all that stuff with SML. And now we are actively working on these things, and I think in the next few months all of that will be out, and it will be almost like on par with like the existing voices.
So what do I have to do to be a beta tester is my first question. Kind of hear from what you're saying there that your vision for this next generation is maybe less about like an SSML, which makes sense given what you've told me about the market, right? You don't see the big opportunity in terms of like taking share from systems that are still in production that do support SSML, but rather it sounds more like we're headed for kind of prompt engineering for voices. So I'm imagining myself kind of being like the moment that, a grandfather first saw his, grandbaby, and like getting the voice to come out with the appropriate emotion from those kinds of like qualitative scenario narrative type descriptions, which, is, I think, what a director on set would say to an actor, right? They certainly don't give them SSML notation. So am I getting where you're going there? Like, are we all about to become prompt engineers / directors?
Exactly. I think like our goal in this, like eventually, is that we have something that people can totally control the voice. And I think that you spoke earlier about the transition from like a text-to-speech company to an AI company. And that now in text-to-speech, you have like a specific set of voices that turn any text into that voice speech, right? But now we want to have like a lot more control on the designing the speakers, like the actual voices, like that you can, okay, I want this voice to, because this is actually what happens. Like I want a voice that sounds like, Optimus Prime voice, like, the deep voice was like, but, like it will be a little bit like slower. So this is how people actually think about like content creation. And if you think about the future of content creation, it would be something like this. People are just becoming narrators, where they just describe what they want, and then, it will be generated, and they start using it. Like instead of them actually sitting and doing the work themselves, they will become they're just describing, like what's happening with images now, right? You're just describing what you want, and you generate it, then you iterate over it again and again until you have the exact things that you had in mind. The things that used to take days from like artists or designers, right now it can be done in minutes if someone has the right ideas and how to iterate over this and help like to guide this like machine or this model into the right direction of generating what you want. And I think the same is happening with voice, where you will be able to design these speakers and create voices that exactly what you want, and then start using them. So I totally agree with you. I think this is where it's going.
You mentioned briefly earlier the fact that these models are in some sense non-deterministic, and there is some level of just like GPU indeterminacy, which is basically irresolvable at like the software level right now, or at least would be extremely difficult to avoid. But I also understand that that's like pretty rare and only kind of comes up when, values are very close to kind of rounding points anyway. So is that what you mean by like you can't make them determinate?
Okay, there are 2 points there. The first thing, I'm comparing this with the previous generation of models where it is very deterministic. Like if you put the same text with the same voice generated 10 times, they will be identical. There'll be no difference. But then with this thing, if you put the same voice and generate 10 samples, they will be different, like one sample from the other. There might be a very slight difference. Sometimes it's a little bit more, like more than what you want, like big difference in the way a specific word is being said or something. And that with text to speech, that determinism, that means that the user can't just come drop in an audiobook and click convert and just get and forget about it, right? He needs to sit and make sure like it is actually exactly as he wants, like what he wants. And that introduces a problem based on the use case. Some use cases people actually want to do this. They also want to come with a big document, drop it there, and have something that's 100% works, like say things exactly like what they want in the same specific styles. But in some other use cases, that actually is a feature where you want to generate again and again and see which intonation. Like it's like compare it with images, like where you generate 10 images and you can maybe choose the third one because it's exactly like what you had in mind, and then you iterate more over this. And so exactly it's the same case here. So we allow users to generate like multiple samples and they listen to them and they choose the right one. And the good thing about this, that this data also is very valuable for actually guiding the model, like what people prefer to use in in like different scenarios. So like this is like the point of like undeterminism there, where another point with especially things like acronyms or something, like where sometimes when you generate again, the model might pronounce like, because there's some words that the model never heard about before. If it's like a company name or like some weird acronym or something like this, like it might be hard for it like to get it like right every time. Now we have people in the team who have like a long experience in speech processing, and now we started doing some stuff that the traditional models like used to do to make sure we have this like phonetic representation of like words and pronunciations, and try to like freeze that stuff in the model where it will always like generate these words in that way, while still keeping the undeterminism for the other stuff like going on. And the good thing about also voice, if you again compare it with humans, I mean, if you ask the same person to read the same sentence 10 times, there will be actually difference. It will not be the same all 10 times. Might be slight difference, but there is a difference. So, and people are okay with that. But then it comes the issues when like with pronunciations or with if this undetermined or like this random like generations are for specific words are not carrying the right emotions or style they want. And that stuff we need to give them the control to do this when they want. And but by default it should be, users should be able to discover like these different styles in like this like randomness and be able to select the one that matches what they think is the right way of saying this. Again, matching exactly how humans speak.
On like a technical level, is there sort of a setting that you could also think about exposing that could be like the equivalent of a temperature?
Actually, yes. Like, and these new models that we're creating, they're actually a lot more than just temperature and like specific seed you want the model to use or something. They're like things like how like the voice guidance, like when you try especially to clone a voice, for example, you want it to be identical, how much resemblance you want it to be the original voice versus to be like a little bit like it, like you want it to preserve the same accent, you want it to be exactly like that voice or no. So like there are a lot more when it comes to voice, like, and some stuff like a lot related to like some attributes of the voice itself, like its style, it's like gender, it's for example, like you can add to a voice, you can add it to make it like a female, but if the main voice is male, it will become a little bit feminine, but like it will be still like a male voice. But so there are a lot of like good stuff that people can start using and tweaking exactly how they want the voice to sound, and then start using this. So that's stuff that we're actually starting to expose to users to use and be able to have more control on designing these speakers that they'll be using.
This conversation and just the way you're speaking about your product does actually remind me a lot of talking to Suhail for the first episode, just because control, control, right? We've got this amazing technology now. It's blowing people's minds. And now how do we rein it in and really make it work for us? You guys obviously have different versions of that challenge, but it's fascinating to hear, conceptually how much commonality there is. Let's talk about languages just for a second. Is it just a matter of lack of training data that is, and maybe also market, but from a technical standpoint, is it just lack of training data that prevents you from expanding the ultra realistic voices to other languages?
Actually, not just the training data. You don't need the same amount of data for other languages. We have created internally some like Japanese and like Portuguese voices, and the result was actually like better than what's available on like AWS and these APIs only from maybe like 10 hours of audio, because the base model knows how to speak very well like humans. Now you just need to train it how to speak like a Portuguese accent, for example, right? And the other challenge there, like, because our model wasn't trained on phonemes, so sometimes like these other languages will have specific types of characters, or like especially with the non-English, not like the voices are not what's it called, like they don't have like the Roman like scripting. They will have like just Japanese, like, or like these languages. You need to train like what's called like a G2P, or like you need to train like a phoneme encoder to be able to understand like like that script when you give it to the model to translate. And once you do that and the model can just understand phonemes, it doesn't matter. You can just train it on any language or fine tune it on any language. Another thing we're doing now is just we are actually going to train like a large language model that just from scratch that has like that's multilingual. The reason for this that we think that we will start to see some capabilities of like cross language like speaking, where right now actually we have it for English, that if you upload like a voice, if you try to clone a voice in that speaking in, for example, French, and if you go there, like you clone the voice, it's available in your like studio, you can then start using it, you will get like an English voice with a French accent. Like, I honestly didn't expect that this will work. Like, and I was like mind blowing when I saw it, but it works so well. And we tried many voices across like, and it works like even a lot better with the new model we're training. Even with like few shot training, you show it literally like a 30 seconds of like a Japanese accent, and you will get an English person talking, but with the same accent, basically the same voice, but speaking English, but with, it's like as if like a Japanese person starts to speak English and he has the accent. It is like amazing. And you can think about the capabilities of this with something like dubbing, for example. You can have the same actor like across languages, same talking in the same voice, but in that different language. And then so one of the reasons we're thinking of training that like multilingual model, that to start seeing this like not only from any language to English like what you have now, but just across languages. You can have the same voice, so you design the voice for your game or your audiobook or whatever, and you love this voice and the way it talks and tone or everything, and then you want to just take this and make it available in every language in the same voice, but then speaking that language. So this is what we're trying to do.
Does the compute itself come with a huge price tag for you guys? And how do you manage that? Do you do it just on your own in the cloud, or do you work with like a Mosaic or some sort of like specialist large model training company?
Currently, we're doing everything on our own, but usually inference is not expensive. Like inference is like, I mean, and users are paying for inference, so it's not like a problem. And right now, the model is very optimized. That even for voice clones, we build like that like infrastructure that can load, unload like all models on the fly in the GPU memory and handle like hundreds of models per GPU. So we have like did a lot of work on optimizations on that infrastructure side, so it can scale really well now. So there's no problem with the usage side when the users are using and scaling that. But the problem more is, or the cost comes more with training. Like this model we're training now, like we're finishing it. Actually, it cost us like hundreds of thousands of dollars to get. I mean, it's not like millions, like these other like large language models, but still for a startup, that's like a lot of money. And the good thing is that we have been in this market for a very long time, like for like 3 years now. We have a lot of customers, and we have like very like decent revenue that's covering everything so far. So I think that's not a challenge for us now. The challenge will be if we really want to scale this a lot more in training and experimentation. And also, most of the cost, what we found, is not only in training this one large model, but actually it's a lot more in experimentation, training like much smaller models to, for example, when we did this with like Japanese and Portuguese, wanted to know, is that actually doable? Is that like, can you just fine tune this on another language and it works if you train this on phonemes? So this took like a couple of weeks, not months to train, but then this experimentation, and we do a lot of these experiments to improve the models, to do these things like we have been talking about with like control and phonemes and pronunciations and languages. So this continuous experimentation is actually, it's like an R&D department. We have like, it costs a lot of money, and I think that sort of, it's still like working fine with us, but over time, I think these models will reach a point where we'll exactly have what we want, and hopefully we don't need to do the same investment again in to get like the same feature, because right now it's lacking on a lot of features in the existing models, and we're trying to get there in all these features. So one of the reasons for that also is that we are trying to train our own models. We're not using an API or something from another company or something that's already open source. So that also comes with that cost. You're just sort of trying to build the operating system and the applications at the same time, right? So yeah, I think this is like where most of the cost is.
Just kind of thinking out long term, one of the things you said there triggered a thought for me, which is just like voice, unlike other things, seems to hit, just even conceptually, a certain kind of plateau when it achieves like human voice actor level. I don't know necessarily what it would mean. I do know what it would mean to be superhuman at, many tasks. But when it comes to producing human voice, like, almost definitionally, like you can only be so good. And then you're beyond like what is superhuman, right? In that domain. So do you see things kind of leveling off at a point where like the models are so good that they can kind of do what you want them to do and you can kind of stage direct them, and they're like easy to use? Do you see that the core technology at some point becomes like commoditized and even like open source and just kind of generally accessible?
There are two questions there. Like one on the model itself, like what will happen to this? Will this become a commodity? And another thing on, if this became a commodity, what will happen to the applications on top of this, right? So like for the model itself, I think eventually like the improvements you're trying to make on the base model will start to give you like diminishing returns, where like, like speech recognition, for example, like they reached a point where, okay, right now every speech recognition system is like 95% good. To move from 95% to 98%, it needs a lot of work, but based on the use case, almost all of them are like 95% accurate or something. So I actually don't know, but like I think they're all pretty good now. So I think the same will happen with voice, but then the difference we're seeing here will be this, that yes, there might be some open source or an API available in like a year or two from now that has similar quality to what we have today. But then for the specific use cases, to be able to generate voices and have like these specific workflows for gamers, for example, or for like people who are working on animation movies or these things, I think mostly we will need to train like some specialized models or fine-tune like on their data, like something that is specialized that can give them exactly what they need. And that wouldn't make sense for example, OpenAI, if they have like a model that's available and very cheap, or Stability if they have like a model that's available, and open source, because they are trying to build something that's generic that everyone is using, right? But we are interested in specific verticals, specific use cases where we can go and build like these specialized models for these use cases that works really well in what they want. And the other thing is, if you think about, we are now talking about also the use cases that have data sets available like publicly, right? But if you think about things like customer support or like sales calls or like these things, you cannot go anywhere and find 10,000, 50,000 hours of customer support calls, right? Like now we're working with some like some partners who have this data like that's available, but and private data from like their customers, and then we can train that model and provide them a solution that replaces customer support, for example. But no one will be able to compete with this because like this data is not available for anyone to train and have a variation, and it wouldn't make sense for everyone to have 100 models for all different use cases. So I think this is where we can start having something that's different from the market. And the other thing is, for example, like Copilot has been in the market for like 2 years now, like 2.5 years. And I'm not sure if you know that like almost all FANG, like all the large companies, no one is using Copilot, even though it's like so good, like it saves you a lot of time. But why they're not using it? Because they are afraid if they use it, like their data will be like leaked to like I don't know OpenAI or like whatever for like privacy reasons. So that's another thing that like these companies who want to create, like right now we're talking with some like big production studios who are very careful about the voices, like they have actual actors, like they're like the and they want us to clone their voices to use in post production in these use cases, and they're very careful about this. And we would have mostly to just give them like some in-house deployment of the model trained on their voices, on their actors, because if something like that leaked, that's a big problem for them, right? So I think these things were for enterprises and these big production companies where you will have to have like a solution that's specialized and deployed internally to keep the privacy and like these things for them. I think that will be something that can like protect like the business from just like opening this for everyone. But I agree with you that the individual use case over time will become very competitive. When OpenAI, for example, like opens an API for this, everyone will start building applications, like, and so many startups will start building something similar, right, to what we're doing. And the individual use case will become very competitive. But then the companies like production or gaming or like the enterprise use cases, they will still need something like specialized for them. And the other thing on the application side, this is where the difference between like building the operating system and the applications. Right now we are doing both, but eventually going deep into these verticals and building more tools for them around what we're doing, this also will be something that will be special to like what like our offering for them. Like, to give you an example, I mean, even not with this model, with the old models we had a team from Amazon using us, and they have AWS Poly. But the reason for that, they didn't want to go hire a developer and build their own solution, right? Like they just wanted something ready they can use and start, getting their job done. And the same will happen here. If OpenAI has an API tomorrow, or like anyone else, like the same will happen. Like companies will continue to use the applications that has a UI they can just use and get their job done quickly.
I think it's one of the best rundowns of long-term moats that I've heard. And, it really echoes also what OpenAI is doing and kind of, the new market reality that they're creating right now in the language model space. It is striking to see that is now at $2 per million tokens, functionally free for a lot of use cases. But at the same time, they're doing exactly what you're alluding to, which is they're going and selling 7-figure deals to major companies that have data that, and I don't know if they're doing any on-prem offerings at this point or not, but certainly walling things off from other people's data, all that is going to be a huge concern for them and for their customers, especially driving it. So it makes total sense that you would feel some of those same, tugs and be moving in some of those same directions.
Everyone is asking this question, like will this be all these foundational models, will that be commoditized and just everyone will have it and there will be no value in that? But I think what this question misses is that like this is just like an operating system that then there's like two things there, like these like specialized things that you can build for enterprises and for specific use cases, and then the applications that can be built on top of this. Because there are different layers of this, right? Like exactly like in cloud, for example, right? There's like AWS and Azure, but then there's so many application layers on top of that still make a lot of money and like make like huge businesses with that.
So let's go back to cloning then for a second. I think this is going to be, one of the most powerful features or use cases that you offer. It's certainly in time, if not already, will become one of the more controversial as well. At this point, you can go into Play.ht and upload 10 minutes of audio of you speaking. And I was able to send you the first question from my list of questions in my voice generated on Play.ht. It was honestly all very easy, very smooth. And it was, as much as I have shopped for this product, I confess it was the first time I cloned my own voice. And it was kind of a wow moment. Again, as much as I've shopped for this, like hearing myself come out of the machine, and it really does have obviously a very high resemblance to my voice. I thought that was, kind of eye-opening. So what are people doing with cloned voices? How much of the usage is that? And then obviously, we got to talk a little bit about kind of the societal impact and the potential for abuse. So I'm curious to know if you're already starting to see some of that as well.
You can get like almost 100% resemblance. I have multiple times where users will send us, say, I sent this to my wife and she didn't know it's an AI voice. Like, and like one of the things we are experimenting with just about like voice cloning. So, we had this idea of what if we make phone calls to sell our product? To make this like, sales, like we have like SDRs and our team started hiring them like to make phone calls, reach out to people, do outbound and like, sell our product to companies. They say, okay, you know what? Like when I listen to these calls, they seem very basic. Hey, are you interested in this product? Yes, no, okay, let's have a call. So we did like, we hooked up ChatGPT with our voices, and we started making these calls. And we were very surprised that no one figured out it's an AI voice on the call. Like that was very surprising because like we're saying, actually maybe people will like feel like it's an AI voice and they will, hang up or something. Like no one, it's like just normal conversations. It's like actually we're like just thinking to share some samples on Twitter or something, but now this technology is becoming like very, very good in this, that as you said, it's also dangerous. So right now, like about the abuse issue, and that's something that we thought about a lot. And actually one of the reasons we spend a lot of time, that's available from day one. The model can clone any voice, right? Actually, all the voices we have now available, these are just voice clones, voice over actors that we got and cloned their voices and now making them available for everyone to use. So, but we were very careful about like releasing this, that we started by just, like asking people to sign up, have a call with us, try to understand what they want to use this for, what are the use cases, because we didn't know. That's a new market for us for like voice cloning, and we wanted to know what people would be using that for. And we spent probably a couple of months just having a lot of calls with these customers, trying to understand their use cases. And out of this came a lot of like YouTubers and podcasters, and these use cases, starting to understand them more. And then when we launched it, at the beginning, it was very strict process, that a lot of like manual reviews, and it wasn't scalable at all, because we have been very careful about abuse here. Until we only opened it up like as like the thing that you used now. When we did two things, when we added moderation, when we managed to add moderation to our studio, where right now everything going through the API is going through like a very strict like moderation policy, that if you try to like, you can try to go and put something like, I know something very offensive or racist, and it's really hard to make this right. I'm sure you know that, but we're trying to be. It's okay to have some, false positives there, like we might end up like blocking some users by mistake or like stuff like this, compared to having someone like being harmed through this technology. And so we did this like we added this moderation through our APIs, our platform, and we tested it well. And the other thing we added is that we built this classifier, and this is like very hard problem to solve. That building that discriminator, and I know OpenAI actually trying also to build this for ChatGPT, that can tell if a content is actually human generated or AI generated. And we built that classifier, and it's available publicly on our website for free, that anyone can go drop like an AI generated like audio and be able to tell if it's AI generated or human generated. And I know this doesn't block abuse in itself, but we're hoping that this will start to advance and hopefully like more and more people can, like when this classifier like being advanced and being able to detect a lot more of these cases of like AI content, it will like maybe be integrated in like social media or like on other or with banks or like with these like entities that depend on like voice as like a way of like logging into your account of like your biometrics or with or like that stuff like that on YouTube or other places where you have some maybe fake news or something. And hopefully these platforms can have some message to inform the user. Okay, like what Twitter has now with community, what was it called, community signals or something, like where community notes where they have this message. Okay, this content this is wrong. This is not like the real thing. That this is what's real. And maybe if they have something integrated like this, they can start to tell people this is actually wrong. Right now, some people are using other services to create fake ads on TikTok from like Joe Rogan voice and these things. Like he's recommending some product. It's very dangerous, right? Like and like some people, I was reading an article a couple of days ago, someone used like a service like this to defraud a family and to like thinking that their son is in jail and they need to send them money or something like this. So it's very like that stuff is very dangerous to do. So we're trying to I think like what like Sam Altman was saying, that like he's hoping like that this technology like AGI like will take a little bit of time until like like the society, I'm like paraphrasing here, like until the society like gets used to like gets adapted to that technology. So I think it is even more like so for voice, because for images the society is already sort of ready for like generated images. Like you already doubt anything you see in social media now. It might be photoshopped or like something that had been there for like 10 years. But for voice, if you hear a voice saying something, if you get a call from your brother telling you something, you don't like, I mean, the first impression is not like, are you, the real person, or that's not right. That's not right. Like you just, because that's not yet like very common in society that these things are so real. But this will happen over time. They will have a doubt like for everything, like any media you see, the first thing you will have in your mind is that actually real, or is that a deep fake? Because right now this will become so real that you cannot tell the difference, and it will become worse over time. So I think it is like a matter of like like responsible companies who try to like have the tools and like in place, and have the things as much as possible to block like the abusers. And at the same time, like like the society is over time getting used to the fact that now voice cloning and deep fakes, and the same will happen soon with like videos. Right now lip syncing is becoming very good, that there are some like videos like you can see with just like some like lip synced voice of like Joe Rogan or like other, or like Biden or like other people like saying something they didn't say, and that's very dangerous. But the society like over time will get used to that, like to not trust, like to see something like on any source. I don't know what's the solution for this for the society, but I mean we're trying to be in the middle where we mitigate the abuse as much as we can through these tools and the moderation, and at the same time offer a service to users that they will find it useful and easy to use.
Yeah, that all makes sense. It's a tough challenge, and you're not by any means alone in facing it. Two really quick follow-ups there. One, on your discriminator, is that something that works like across audio generated by other text-to-speech products as well? Or does it depend on like a signal that you're embedding in, or or maybe just naturally occurs in the audio that you create?
It depends. So it catches some stuff. What we noticed from like testing it from our models and from other stuff in the market, but it's less so from the other stuff on the market, and it can get a lot better. I think this is just like the first version of it. Like this can get a lot better in detecting, because these voices generated through transformers, vocoders, and like these models, they have specific. They leave behind some specific things that you can detect, and you can over time, if you really invest in this across different types of vocoders and like approaches of generating like decoding the audio to create like waveforms and that stuff, you can start like you can start to reach a point where it will be very accurate. But again, I think it's a very hard problem to solve, like to have something that's very like a discriminator that's like very good in detecting any AI generated content, that's a very hard problem to solve. But having something that's accurate enough, I think it can at least mitigate a lot of abuse if it's deployed in the right places. And it's the same idea was like fake news and like these things. So I think it can, like, the idea here is to make it, you can, if you can't mitigate that like 100%, at least make it like 90%, so most of the abuse is mitigated, and trying to do like as much as you can here.
Is there any way to detect like commonly abused voices? I mean, I'm sure there would be a way if you had a small enough set. If it was just Joe Rogan and Joe Biden, you could probably, solve that relatively easily. But is there a way to kind of extend that? Do you think it would be realistic to extend that to the 100,000, most well-known people that folks might want to clone and abuse a voice of?
Yeah, we actually thought about this. So there are some data sets there for celebrities, for example, but the problem there, and you can build the classifiers to detect these voices and flag, like if the user tries to clone like a celebrity voice. But the reason we didn't invest in this, because we found actually cloning celebrity voices maybe is not the most dangerous thing, but the most dangerous thing is cloning maybe like politicians or voices of common people and defrauding them, right? Because like when you're running a scam trying to get into someone's bank account with his voice, I mean, we will never be able to find that person's voice and put it in the classifier, right? That actually is the most dangerous thing. And that's why we went with the approach of, okay, when someone clones a voice, what will they do with it? They will try to use our API or editor and write some text and generate audio in that voice. And then we thought like having this moderation layer and then flagging these users and blocking them, this can be a lot more effective than just having a database of like voices that we can detect.
I've done a little bit of this kind of red teaming work on language models. And in that context, yeah, it makes total sense, right? Like, what is the content? People asking for somebody's, mother's maiden name is probably a pretty good red flag, that they're up to no good.
If you imagine, so if we started to have like some like humans like moderating these use cases, and I think we have like a large language model or something that we can fine tune on this data and be able to tell with some probability if someone is, because sometimes if someone's trying to get into someone's bank account, the classifier might not detect it for moderation. But if over time you start to detect these use cases that's like going through like these cracks of the moderation detection, and then you add these things there, over time I think it will get better and better in that, a lot more than just if you try to detect the voices and block users based on this.
Really enjoyed learning a lot about how you're thinking about the business, how you're thinking about the technology. I'm, very excited to see the next generation larger model and all of the, prompt engineering or stage direction type of use cases and modes that it's going to unlock. It sounds like you're really on the verge of another big step forward. So I'm excited to see that. I've got 3 kind of quick hit closing questions for you. First one is, what are the AI tools that you are using in your day-to-day life right now that you would recommend that others check out?
I think definitely ChatGPT. Like, I'm using it now for like summarizing things. If I have like a very long email, I'll just like drop it there, ask it to summarize it, or more also for writing any code now. It's just like it doesn't make sense to do something else. I use it and keep asking it, okay, like change this from Python to JavaScript or like whatever, and like do like all the things that you want to do. So it is really good at this. I do use Grammarly also, so I think it is. They have actually, I think they are like one of the biggest like maybe AI tools like before ChatGPT is Grammarly, but like no one sort of like knows about it. But I use it also like a lot. It gives like a lot of good suggestions now when you're writing emails or these things based on the context you're doing.
Yeah, ChatGPT is certainly the number one answer there. You're actually not the first to mention Grammarly as well. Do I infer that like ChatGPT has kind of crowded out Copilot? Like you are finding that you just want to go to the better AI to do kind of longer code generations?
I think like I'm still using Copilot, but like mostly when I'm starting something, like writing something new, and I want to just like like ChatGPT feels like not like an auto completion, like how like you might get from Copilot, but it is just it's like you're having another developer next to you and you're thinking about different things. Okay, you know what? Like let's change this from this let's add some like rate limiting here. How would this work? And then you write this and send it as a code and wait for the response. Okay, you know what? Like let's change this from this language to that language. Like that's like very quickly, these iterations until you reach something that you want to use, and then you take this into your editor, and then you can use like Copilot there. So I'm seeing like I feel like that chat based like coding. I've never expected this. Like, I mean, if you describe this to me like a year ago, I would say I would never use this, but it is actually pretty good. It reminds me as at like in my career, sometimes I would have interns working with me, and it is very similar to that. It's like you're working with an intern and asking him to do something, and then he will go do it, and then comes back with it, and then you like think with him like another iteration, and then he will do the same. It feels very similar to that.
Yeah, I think that's very apt. I use that metaphor pretty often these days too, and it works on kind of a couple different levels, right? Like it needs a lot of context. It's it really benefits from a couple examples of what good looks like, aka few shot learning. So there are, I think, a couple of pretty profound parallels there to the intern that does make that a useful way to help people, especially if they're new to the technology, to understand how they can get the most out of it. A hypothetical situation. I'm sure you're familiar with the company Neuralink. Let's imagine sometime from now, I don't know how far into the future this will be, that 1 million people already have a Neuralink implant. So you're not going to be the first, but the question is, would you want to be the 1 millionth and first if getting the Neuralink implant would allow you to basically have thought to speech? Like you could type as fast as you could, as fast as you can think, your words can just be, your thoughts can be translated to words and stored in the computer. Would you be interested in getting that implant for that capability?
I think I might try it before 1 million even. It's like I mean it's just like it's amazing, like so exciting thing to see. I mean if this works, because like the main thing there is that like the bandwidth for humans, like you think about something and then you have to write it and do this like thing yourself, your manual physical thing. But then if you're able to change your thoughts to maybe to like a machine directly and have it like interact with it, like the bandwidth would be like a lot more like a lot like bigger and wider than if you're just using your own like hands to describe something and stuff like this. So I think it will be so powerful, and people who will have this, they will start to advance really quickly into like what they can do and like their capabilities. And I mean it has to be safe, of course, but like I would try it for sure.
Just zooming out entirely, kind of biggest picture, what are your biggest hopes for and also fears for the AI era that we are entering, kind of as you think about how things will play out over the rest of the decade?
Yeah, I've been thinking a lot about like this like AI safety stuff, and I don't know, I will not like comment on this, but like from because there's so many opinions there and so many people like say like different things about like try to predict what will happen in the future. But like I think like what I hope like will be is that the community, like the society, will get a chance to adapt to these changes, and this will be very empowering, and these tools will help us to be like a lot more productive and there'll be like a lot more progress for humans in the next like 10 years, or like I hope that will be like a lot more positive. And what I hope doesn't happen is that like the legal side of the legalization of this technology now, like we're seeing now with Stability getting sued because of like what they're trying to do, like and like there might be, I hope that doesn't introduce another winter to the technology and like delay it a lot. Because if this happens in like these markets, like they're trying to be responsible, it will still like other markets who are not as responsible will still keep it open, and they will be able to advance a lot faster. So it is very important that like that the legalization of that can be like when you think about something like with the internet, like, with like platforms like Facebook and Twitter and these things not being like responsible for like that users are posting on their platform, you can argue the benefits and like the disadvantages of something like this, but you cannot argue that that is one of the reasons that made this platform huge and really big and impactful and useful for a lot of people. And if that wasn't the case, that like everyone who posts something that you can just go and sue like Facebook for it, like they would have died like a long time ago, right? So I hope that the society overall will be able to adapt, help like progressing that technology into the benefit of humans. And because I think it can be really useful and people can become a lot more efficient and productive, and like the overall gain for like the society can be huge from a technology like this.
Again, this has been a fantastic conversation. Mahmoud Felfel, thank you for being part of the cognitive revolution.
Thanks, Nathan. I enjoyed it. Thank you so much.
Omniki uses generative AI to enable you to launch hundreds of thousands of ad iterations that actually work, customized across all platforms with a click of a button. I believe in Omniki so much that I invested in it, and I recommend you use it too. Use CogRev to get a 10% discount.